So, so I'm Jonathan Butz, Solutions Director for Healthcare at VMware in the East region. I want to have a conversation today about software-defined data center and what it means for healthcare today in the face of a changing economic environment. Meaningful Use 3 is right around the corner, which means quality of care and patient satisfaction is going to have an impact on revenue. And the industry as a whole is anticipating a revenue decline as a result of this. So this is an important external economic pressure that we have to keep in mind. At the same time, the healthcare systems in general are asking us to deliver ever-increasing capabilities, increased levels of security, increased mobility, increased capability across the board. But at the same time, they're being asked to do this with a flat or slowly growing budget, and that presents a number of challenges, obviously. In general, we're seeing IT budgets ranging anywhere from 3 to 8%, and a pressure across the board to shrink those budgets to get them down into the range of 3 to 5%. We also have an interesting evolutionary change happening in IT infrastructure as a whole, not just in healthcare, and that is the looming possibility and potential of the cloud and what that means across the board from a cost and efficiency, scalability, et cetera, perspective. So for 2 years now, the CIOs at Chime have told us that they intend to exit the data center business within 3 to 7 years. And that's a very interesting perspective to have them maintain, because it's very easy to say, but it will be much more difficult to do. So with all of these external pressures and the way forward in mind, let's talk about where we're headed in the long run and what really still exists to be done in the short term to operate our data centers in an efficient way, and what that means for everybody in healthcare today, from hands-on administrators up through the CIO and CTO and to the office of the CFO. So we're making a lot of assumptions about cloud in general, that it's going to be a cheaper way to run IT. But a lot of that is still speculation. There's still some gaps in terms of capability that we don't need to go into detail today. But even if we decide today that the capabilities match our needs and that the price is right, it will still take 2 to 4 years to effect a true migration from on-premise infrastructure to cloud. And that means we've got at least 3, probably 5 years of continued on-premise operation and expansion before cloud is a reality. So with that in mind, we as responsible stewards of IT budget and managers of on-premise infrastructure need to continue to adopt technologies that will allow us to optimize IT spend and deliver the increased capabilities that our businesses need in the short term, in the 3 to 5 year time frame. And how do we do that? Well, the answer is an extension of what we've been doing to date. We've been building the same infrastructure for quite some time, and this is our scalable compute and memory layer backed by a highly available storage infrastructure. And we'll ignore the communications piece for now, but that's important as well. But the challenge with this is one of the reasons that our IT costs are so high, and there's huge opportunity to revamp the capabilities, to deliver the same outcomes that this infrastructure delivers at a lower price point with reduced complexity. And we'll show you what I mean by that. So let's talk a little bit about the impact of the software-defined data center from a spend perspective. And I think one of the most effective ways to do that is to just talk about the spend in our environment. It's tempting to group VMware among the software that you purchase to run your data center. List it alongside the likes of your EMR and Microsoft. But it would be better to recategorize some of the software in our environment You know, the EMR is a cost of doing business. You are a healthcare system, therefore you need an EMR. It's simply a cost of doing business. Microsoft, likewise, you know, the applications that you deliver run on Windows. Writing a check to Microsoft is another cost of doing business. Really, the spend that we want to focus on is infrastructure. So what does the infrastructure spend of a healthcare data center look like? Well, it's about half storage. 40 to 60% is storage. And then the next largest piece is generally networking. And this is 20 to 30% networking. And then 15 to 25% is compute. And then VMware represents a very, very small portion of the overall infrastructure spend. Now, by leveraging new capabilities that the software-defined data center provides, software-defined storage and virtual networking, we can impact the largest portions of this pie. Storage, networking, and compute are all up for grabs. They can all be reduced. We can make a dent in storage to the tune of 30 to 50%. We can make a dent in networking to the tune of 20 to 40%. We can make a dent in compute from the tune of 20 to 30%. And all of these do require an additional investment in VMware, but even doubling the required investment in VMware has a significant impact. So let's talk about some of the savings opportunities and where they come with a real customer example. So one of our customers was faced with a net new expansion opportunity to support some Tier 2 and Tier 3 applications. So they quoted their business as usual option, which was EMC storage expansion to the tune of $1.7 million. Then they quoted a vSAN option using UCS and vSAN, because they were rack mount UCS, or they were blade-based UCS, so they needed rack mount UCS. And that total for that solution, $1.1 million. So this is really important to contrast these two solutions. This is storage only, and this is compute and storage together to deliver the same capability for 50% less. This is a big deal. This is why going after the 50% of that pie is relevant to our customers. And this, by the way, just the upfront capital. We're not even talking about the fully loaded total cost over the life of the gear, which makes this even more compelling. So the last option they quoted, just for fun, was Dell and vSAN. Again, same outcomes, same capabilities, different packaging, $850K. This is a huge range of upfront capital costs. This is really relevant for all of our customers. And the challenge here, of course, is always, in all things, the biggest threat is business as usual. Wanting to do what we did yesterday because we're comfortable doing it, because they're solutions we're familiar with, and we're comfortable, used to writing these checks. The business wants us to do this. The business wants us to look at these options, which means it's time to quote them, which means we have to get our customers to quote them. Even if they don't yet feel comfortable with the technologies, we have to put them on paper so that we can see how they compare from a cost perspective. Because if we don't, we will simply continue on this path of business as usual to the detriment of our organizations. That was good. So let's talk about what the infrastructure stack looks like today, diving in a little deeper to that earlier picture. You know, at the top of the stack are the applications. That's not going to change. The operating system's not going to change. VMware as the abstraction layer from which we've gotten all of this value to date. Beneath that is the compute, the hardware platform on which all of this runs. And then we have generally fiber channel infrastructure to communicate with the storage and to tie all of the moving parts in our data center together, the network, which really covers more of this stack, but we'll understand why we draw it this way in a minute. So this is complex infrastructure. There's a lot of independent moving parts in this layer that are generally managed independently of one another. They scale independently of one another, and when something goes wrong in this stack, it requires generally many different people with many different tools to troubleshoot and resolve those issues, which would take a great deal of time. Each one of these components, a lot of these components are very expensive. They represent a great deal of data center spend. So there's a better way. There's a simpler way to deliver all of this infrastructure. And so we acknowledge that the applications and the operating system are with us to stay. But we can tie a lot of these components in the middle into one idea, and that's the VMware software-defined data center that ties together the compute, the storage, and elements of the network together in a single manageable pool of resources that scales in a much more modular fashion. And we can do this by leveraging the Evo platform and the vSAN Ready reference architectures from a number of different vendors. And really why this matters is, one of the ways that we're looking to scale our infrastructure and our staff is by reducing the complexity, simply reducing the number of things that can go wrong in a given environment. And this is the way to do it, because there are so many different combinations of hardware, firmware, drivers, etc. in this stack. By moving to a reference architecture, we narrow the number of possibilities substantially, which means we substantially reduce the number of things that can go wrong. At the same time, we're dramatically reducing a lot of the spend associated with some of these individual pieces. Now, the network merits a different conversation altogether. The role of the network changes in this model. In the traditional data center model, the network represents both a transport and a security layer, which in general restricts the vendors with whom we can deal and makes the importance and complexity of this infrastructure very, very high. In this model, the network is reduced to a transport layer, and we move the security capabilities up into the software-defined data center construct, and it has a number of advantages. One, we open this layer. This is one of the few layers in environments today where there isn't actually any vendor choice. Very few people are quoting alternatives to their primary network vendor when they need new capabilities or they need to expand their capacity. In this model, by reducing what the network actually delivers to just transport, moving packets from point A to point B, we open this up to choice. And when you open this up to choice, there's an opportunity for savings. So, just to sum up the objectives of this, we're dramatically simplifying the infrastructure itself, and we're dramatically reducing the price that required to deliver the same capabilities. So let's quickly recap the value of the software-defined data center and what it brings to the table. So we're talking about increased simplicity across the board, which has value from an operating perspective in a way that's very difficult to calculate because it affects full-time scalability, full-time resource scalability. It affects troubleshootability. It affects the number of things that simply can go wrong with the environment overall. Reduce storage cost, reduce networking cost, increase security capabilities, the ability to move security up higher into the stack, administer it closer to the applications, and reduce the total amount of traffic in the environment and have a much more granular security policy without additional effort. It's really, really important. And the ability to scale our full-time employees, which of course is a result of all of these other things. So we talked about the value that the software-defined data center brings to the back office data center, but let's talk about it in the context of end user computing, application delivery, clinical application delivery, et cetera. So we have a number of solutions in the marketplace today. So let's talk about how what we do compares to what the alternative vendors in the marketplace do today. So we'll talk about what VMware does versus the alternatives. And it's really, the alternative solution requires their software, the applications, terminal services, operating system, compute, fiber channel, storage, and networking as both a transport and a security layer. This is a lot of complexity and cost. The same reason that this was complex for the data center, it's even more complex for end user computing and application delivery. Now, VMware, of course, now we have two ways that we deliver this now. We can deliver the applications individually and full desktops. So let's talk about what those solutions look like. So we still have our software, and we still have the applications. We still have terminal services and the operating system, but we greatly simplify how that runs. So the compute, these resources are not gone, but they're fundamentally changed, and they're packaged in a fundamentally different way using the VMware software-defined data center running either on the Evo platform, which is an appliance-based means to deliver compute, memory, storage, and networking all in a single appliance, and of course the vSAN ready nodes, which again are reference architectures designed to deliver all of these software-defined capabilities in a much simpler way. And then for the desktop, similarly, we still have the applications and the OS inside a virtual machine that runs on top of the VMware software-defined data center, running on either Evo or the vSAN ready nodes. And then the network, of course, is still required underneath, but we reduce its role to the transport layer, and we move the security capabilities into the software-defined data center construct closer to the operating system, giving us the availability to create much more granular, much more focused security policies with less work, and open up the networking for choice. So let's talk for just a minute about the ways that we can affect customers' business, we as VMware. There's three ways that we can talk about the impact that our solutions have to a healthcare business. We can talk about the impact to the top line, to the bottom line, and the role in reducing risk. Top line solution, the strongest top line, and so let's talk about a little bit about what these mean before we go on. So top line is anything that we can do that affects the revenue, that makes the business more effective, more efficient, makes it easier to scale, expand, et cetera. And primarily, our end user computing solutions are the strongest in their ability to affect top line growth, because these are the solutions that actually affect the doctor's ability to work. If we can make the applications more available, more seamless, more responsive, less intrusive, we will allow them to see more patients and drive more revenue. Bottom line, and there's one more, is our Care Systems Analytics solution, top line, in terms of making sure that the EMR, the most critical application in the hospital, and the others besides, is available to serve the needs of the doctor so that they can continue to drive revenue by delivering their care. So those two solutions are the two that go to top line in the strongest possible way. Bottom line impact is the savings realized by the software-defined data center. Anything we can do to reduce storage spend, to reduce networking spend, to reduce compute spend, those savings go straight to the bottom line. So specifically, the big opportunities here are software-defined storage, the compute savings from Evo and the vSAN ready infrastructure, and then the last is virtual networking. We talk a lot about the importance of microsegmentation and the increase in security, but the tangential conversation to what virtual networking allows is by moving the security up out of the networking gear and into a software-defined layer that exists above and apart from the gear, we bring in the opportunity for choice in the networking gear, which it does not exist today. The networking vendor that dominates the industry is not put out to bid. Nobody gets competitive quotes from HP or Enterasys when they go to expand their core infrastructure. And much of it is because their security capabilities are tied to the gear. If we reduce the role of the networking gear to transport, moving packets from point A to point B, and we move the security up higher, we can evaluate solutions that deliver the same transport capabilities for 40% less upfront purchase and ongoing operational. So there's a big deal there. There's opportunity there. But then the last one is the risk conversation. So we find risk mitigation in our compliance, care systems compliance solutions, validating that solutions meet certain compliance characteristics, and of course in the virtual networking in the form of microsegmentation, the ability to define much more focused and much more granular, more easily administered security policies that get us closer to the applications, allow us to draw specific boundaries around applications in the environment rather than simply focusing on edge security.